So if I was to talk to you about the distributive property of multiplication, does that mean anything to you? Do you remember anything about that from school?
I remember about multiplication, and I don't have a clue what distributive property means.
All right, no worries. It's a weird kind of thing because it's something which doesn't really, you can't see any point of until you do algebra, but if you do algebra, it doesn't make sense until you think about it in terms of numbers. So think about it in numbers, but don't worry that you won't be able to see why we're doing this yet, because when you do algebra, you go, oh yeah, that really needed to know that.
It's fun just to explore it anyway, I'm finding as we're talking these things through. So.
Yeah, I find it that way.
Yeah.
It's excellent. So multiplication, 6 times 4 is 24, which, as you probably know, as I'm sure you know, so that means you've got 4 and you add it together 6 times.
Yep. Okay.
And that's the same as 4 times 6. That's called the commutative property of multiplication, which is not what we're talking about, but it's like the numbers.
I vaguely remember that.
No, vaguely remember that
word.
Commutative.
That one you just said.
The numbers can commute; they can move around. So 6 times 4, 6 lots of 4, is the same as 4 lots of 6. So we've got 4 columns of 6 there. Same thing, which is, as I say, not what we're talking about. What we're talking about is if we take 4 times 1 plus 5. Now, when you're just looking at numbers, what's in brackets you'll do first. So that just means 4 times 6. But what this property says is that we can distribute the 4 by multiplying the 1 and the 5, which may 4 times 1 plus 4 times 5, which is 4 ones are 4, 4 fives are 20, will be 20.
So the distributing means you can distribute the numbers anywhere you like.
It means you distribute that 4 to each of the other numbers.
Right.
Not everywhere you like, but you can distribute it to the other numbers. But this is about why that actually works. Well, it's not just some convention, it's the way things happen. So if you take that 6 by 4 and then go, well, that's actually 4 lots of 1 and 4 lots of 5. And when you look at it like that, it's really easy to see that that's actually the same as 4 lots of 6, and it can only be that.
Those visuals really work for me.
It's useful like that, isn't it? But if you don't look at it like this, you go, that's a really confusing concept. How does that work? When you see it like this, you go, okay, that
makes sense.
That's how it works. And similarly, if we take that 4 and call it 1 plus 3, and the 6th one we'll call it 1 plus 2 plus 3, and multiply those together, what the distributive property means there is that we multiply the 1 by the 1 by the 2 and the 3, and the 3 by 1, 3 plus 3 plus 2, plus 3 plus 3. Put all that together and did in our heads, 1 times 1, 1 plus 2, 1 times 3, so that's all together, that's 6, plus 3 times 1 is 9, plus 3 times 2 is 6, takes us to 15, plus 3 by 3 is 9, 24. And it works the same way. So we've got the 4 is made up of 1 of 3, and the 6 is made up of 1 and 2 and 3. So all together we've got 1 lot of 1, 1 lot of 2, 1 lot of 3, plus 3 lots, plus 1 lot of 3, plus 2 lots of 3, plus 3 lots of 3. Altogether, it's 1 plus 3 times 1 plus 2 plus 3 can be distributed out. That's the distributive property of multiplication.
So
that's what there is to it.
Just to wrap it up for me, is that so you're distributing a particular number to a particular location. It's not just throw them around anywhere you like.
You're multiplying every possible number from one by every possible number from the other.
Right.
So you're doing all of your options there.
Right.
Is the important part.
Okay.
And it doesn't have to be the same number in each set of brackets.
Yeah.
You're just multiplying them all across.
Okay.
Which, when we get to it, is the basis of a really complicated thing called a convolution, but that's
I can't
fair way down.
I can't wait for that one.
A fair way down the track. For now, it's just the distributive property of multiplication.
Thanks.